Disclaimer. We recognize that some of our metaphors and explanations are flawed, but considering we're dealing with relatively difficult physics, we think they do the best job of getting the gist of the concepts across without misrepresenting the information.
The universe has a speed limit. Thankfully, the laws of physics are fairly generous and have capped the fastest possible speed pretty reasonably. Nothing that we currently know of can move faster than the speed of light, or 299,792,458 meters per second. That is fast. Really, really, really fast.
Now, I know what you're thinking, but will you say, what if I got a rocket to go really close to that speed and then, say, shot a gun from the front of it? Well, it still wouldn't go faster than 299,792,458 meters per second. Strange, I know, and it gets stranger.
Now imagine you're watching a race car go continually faster around its track. For the sake of the metaphor, also imagine this car has a super special top secret engine that allows it to approach light speeds. As the car begins approaching the magic speed limit, you notice it getting shorter and shorter. It appears to be shrinking horizontally, squishing the car and the driver. Worried, you stop the experiment to check on the driver. As the car slows, it begins to return to normal size, and the driver gets out completely unharmed. What you observed wasn't a trick of the eye, but a real physical phenomena, referred to in relativity as a length contraction. The faster an object moves, the shorter it gets.
This behavior is modeled by an equation, where L0 is the stationary length of the object, L is the length observed by a stationary third party, v is the velocity of the object, and c is the speed of light. You can see how when v is small, the difference between L and L0 is hardly noticeable. But as v gets closer to c, the change becomes much more pronounced. Once again, this isn't theoretical, it's not a trick or a theory based on abstract math. As you can see, even the equation that governs it is fairly simple. And as weird as length contraction is, things get infinitely weirder.
Before we start in on the next phenomena, we should establish something you might already be familiar with. Our universe operates in 4 dimensions. The first 3 being physical, and the last being the more abstract, time. This next pill might be slightly harder to swallow. Everything in existence is moving through these 4 dimensions at the speed of light, which is weird, because you obviously exist and probably don't feel like you're moving all that fast. This is due to your speed being divided up unevenly between the dimensions. If your speed in one dimension goes up, your speed has to go down in one or more of the other 3.
Think about it like this. If you're at one end of a basketball court and you want to get to the other end as quickly as possible, it makes sense to travel in a straight line. But if you divide up your path between 2 dimensions, the time it takes for you to cross the court will increase proportionally. You can see how this effect would be compounded if you could run up as well. This trend continues metaphorically in the 4th dimension. The faster you go in the 3 physical dimensions, the slower you go through time.
Time travel into the future is even possible via this method, if you could get going fast enough for long enough. Even more fun than time travel, the equation for this is exactly the same as the last one we discussed. It's worth pointing out that the person or object moving at relativistic speeds wouldn't notice anything out of the ordinary. Their watch would tick on as normal, and they wouldn't feel the least bit squished. Instead, they would observe the opposite effects on their stationary counterpart. They would think that the stationary clocks were running fast, and all stationary objects would appear stretched. This all goes back to relative frames of motion, where the relative in relativity comes from. But you could teach literally an entire class on frames of motion. Probably several. Seriously, ask Jeff.
It's also important to realize that both of these effects are only noticeable at exceptionally high speeds. But once they first start to be observed, they very quickly become obvious. It may seem like we're beating a dead horse here, but this really can't be overstated. These are real physical events, not out there theoretical science. All of the phenomena we've discussed have been proven and observed. We hope we've piqued your interest. There are tons of other equally cool stuff out there to learn about. And if you want to know more about these or any other strange physics oddities, please feel absolutely free to ask Jeff.